Start. Good evening everyone. I am Avinash Agasti, a PhD scholar in the Department of Electrical Engineering at IIT Madras. I specialize in the field of control and optimization. So today we will be beginning the live problem solving sessions for the NPTEL course Control Engineering. Today is the 0th week, you can say. And in these sessions, we will be discussing problems from related to the courses covered in the corresponding weeks. So for week 0, what we'll do is we'll just deal with some very basic problems that denote what prerequisites are required to get into the course. So we'll have some matrix computations and some mathematical basics. So let's begin without any delay. The first problem is, if delta t is a unit impulse function, which of the following is false? So before we get into this, let us look at what the definition of delta t is. We all know what u of t is, that is the unit step function. The unit step function is defined over the entire real numbers, and it gets mapped into the real line as well. Although it takes only two values, 0 and 1. So u of t is equal to 0 for t less than 0, and it is equal to 1 for t greater than equal to 0. Now to define the unit impulse, we want to get something that acts as the derivative of the step function. So we can consider, say, a step function u delta t, which is defined in a manner as such. So what this function does is, for the t less than 0 case, it maps into 0, but for t greater than equal to 0, instead of having a discontinuity and jumping up to the value 1, it takes some delta time to go up. So now we define delta t as d by dt of u delta t as limit delta goes to 0. So we can see that as the limit goes to 0, the slope will be increasing more and more steeply. So in the limit, we denote the delta t function as something by an arrow with value 1, and the value 1 denotes the area under the integral, that is so we see that at least this option is clearly correct. Now next we can check del 0, what does it equal to? So we know that del at 0 is not 0, because we have that arrow kind of thing that denotes the area of the curve. So this one is correct. Then the unit impulse function at some value other than 0 is obviously 0. And so finally we come to this option, which says that the unit impulse function is 0 for all t. Now this is clearly not true. So as we can see, this final option this final option del t equal to 0 for all t is clearly not true, because if that were the case, this is nothing but the trivial 0 function, but that is not the case. So this is the correct answer, as we are searching for which of the following options is false. So now we move on to the next question. If u of t is a unit step, how is a delayed unit step input represented? Now, and we are taking a delay of a units. Now when it comes to questions like this, we can think of it in such a manner. Say u is a function from r to 0, 1, as we discussed in the previous problem. And so what this means is, u takes in value on the real line and gives a value that is either 0 or 1. So at 0, the unit step begins giving the value of 1. So what I want is I want to delay to a value like by some a units. So to delay it, what I would want is I would want the u to think of this point as 0. So when time, so at time, some negative time say, we want it to be 0. No issues with that. Now as the time comes to this region, that is 0 comma a, we still want it to hold as 0. So what we can do is we can take a function like u of t minus a. So in this we can look how it works. So if we put in a t that is less than 0, t is less than 0 means t minus a is less than 0, assuming that a is some positive quantity. So since t minus a is 0, the the step function, u function, takes in a negative value, and we know that step of some negative value, where this is negative, it is nothing but 0. So for negative t we will have 0. Now when we take t as in this range as well, then also t minus a is negative. So again the output of the step function is 0. So we will have this 0 till a, and when it hits a, u of t minus a will be equal to u of 0, and that will finally give us a value of 1, and after this also we will have 1. So when we want to delay a function, we can change the input argument as something of this fashion. So for this question, we have the answer as u of t minus a. So this works not only with the unit step function, the procedure is pretty much similar for any function we can take. To induce a delay, we shift the input by minus a. And similarly, if we did u of t plus a, we can think about it. So if we did u of t plus a, then take this point. On the left of it, that is for t less than minus a. For those arguments, you will take in a negative value. So we will have 0 here without any issues. But as it crosses minus a, t plus a becomes greater than equal to 0. So the unit step will start from here. So I hope that is clear. So to delay a function forward in time, that is to delay it, we need to take an input of this one, and to begin it early, we need to take an input of this one. Now we move on to the next question. Now consider a matrix as shown. It is a 3 cross 3 matrix. We want to find the determinant and what is its rank. Now we know the determinant of any n cross n matrix can be found out by, let's just take by example and solve for this case. So for this case, the determinant of A can be computed by, let us take the first row, that is 1. We'll take 1 and multiply it with its cofactor. Now what is the cofactor of 1? The cofactor of this element is nothing but the determinant this. That is, we remove the row and column involving that element and find the determinant of the remaining elements. So the process is similar then for determinant of a 2 cross 2 matrix. We then repeat that, but we know the determinant of a 2 cross 2 matrix is nothing but cross multiply and subtract. So 1 into 2 minus 3 into 0. So 1 into 2. Now for the second element, we take 2 into its cofactor, which involves the determinant of minus 1, 0, 2, 2. But note that the cofactor is not only the determinant obtained by removing the rows and columns, but also a coefficient of -1 to the power I plus j. That is, for this thing we have 1 plus 1, so it is 2. So -1 to the power 2 is just 1. But for 2, we'll have row 1 plus column 2. So -1 to the power 1 plus 2, that is 3. So -1 to raised to an odd power is negative. So in every alternation, like first we took 1 into its cofactor, so plus 2 into its cofactor will be -1 into the determinant of this thing, which is -2. So we'll have -1 into -2, that is 2. Then similarly for the last one, we'll take this matrix for the cofactor and we'll have 1 into -3 -2. So this is 2 plus 4 minus 5. So this is 1. So the determinant is 1. Now to find the rank of the matrix, we know that the rank of a matrix is defined by how many independent columns it has. That is, if the 3 columns of this matrix are linearly independent or not. Now we can clearly see that none of the columns in the matrix is a direct multiple of other. And also we know that if the rank of a matrix is less than its full rank, that is, if for this 3 cross 3 matrix, if the rank is less than 3, then we would have the determinant to be 0. Now since the determinant is clearly not 0, the determinant is 1, and the 3 columns are linearly independent, the rank of the matrix will be 3. Now I hope this part is clear. We'll move on to the next question. Now to find the inverse of a matrix. So the inverse of any matrix, A inverse, is given by adjoint of A by determinant of A. Now adjoint of A, where say A is A11, A12, A21, A22, is given by the cofactor matrix, that is, we'll take C11, C12, C21, C22 and its transpose, where cofactor is the thing we discussed earlier. We'll remove the rows and columns, compute the determinant and multiply it with -1 raised to the power I plus j. So for this matrix we want to find out V inverse. Now first we can find out the adjoint. The adjoint of V can be given by 2 C12 plus 2 minus 1 minus 2 minus 1. So I hope this part is clear. The cofactor of -1 is only this remaining thing, 2. Then cofactor of 2 is this remaining thing multiplied with -1 raised to the power 3 and so on. Now the adjoint is found out. Now we need to find the determinant, which is -2 into -2, that is -4. So B inverse is -1 by 4, 2 minus 2 minus 1 minus 1. This is so this is the final answer. This is V inverse. So now moving on to the next question. Yes. So for this question, we want to find the eigenvalues of a matrix using MATLAB. So I'll stop sharing this note screen. So I hope the MATLAB screen is visible. So we want to take the matrix C as given in the question. So this we have considered C. Now we want to use the eigenvalue function predefined in MATLAB, and the answer that we get, this provides us the eigenvalues for the matrix. So jumping back to the notes, so for any matrix we can just define the matrix in MATLAB with -2, some space or comma, -4, -2. The semicolon denotes change in the row. Then just hit eigenvalue plus C. So now MATLAB is a really important tool for control engineers because after a certain point, to understand the concepts and get into the groundwork of the theory, it is good to practice by your own hand. But for any practical purposes, MATLAB or any numerical software is pretty handy and often favored over pen and paper based things. So now before that, I just want to discuss another thing. Since we'll be dealing with many matrix computations and similar stuff in the course, I want to say how one particular feature that might help us visualize the multiplication of a matrix with a vector. So now suppose I have a matrix A multiplied with some vector X. Say consider a 3 cross 3 case. Or let's consider a 2 cross 2 case. Now, when we multiply this, we all know how multiplication happens. Now, how can this be written as? We can decompose it. Now, we can clearly see that the multiplication of a matrix with a column vector can be denoted as, this is the first column, this is the second column, this is the first element, this is the second element. So the first column is multiplied by the first element and the second column is multiplied by the second element, and the results are added in the matrix multiplication. So this can be a useful way in visualizing some matrix into a vector, and similarly we can consider for a row into a matrix. So suppose I have x1, x2 and a11, a12, a21, a22. It will be now this can again be decomposed. Yeah, so a row multiplied by a matrix can be decomposed into the first element of the row into the first row of the matrix plus second element of the row into the second row of the matrix. Now this can be generalized for n dimensions as well, but this 2 cross 2 visualization can come handy in further problems or just to help visualize things better. So I hope what I discussed today has been clear, and In further sessions as well, we can, if anyone has any doubt while solving problems, you can unmute yourself and ask the doubt. So I'll be ending the session here. Thank you.